I'm very pleased to be working with KTH for more than a year now. And we have several projects going on and new projects is starting. So just before we start my talk, actually, if you have any good idea for this Sensible Stockholm lab, please reach out to me, and anybody who is already working with MIT and KTH and the City of Stockholm collaboration, that we can always propose new projects. So I will start my talk about what we're doing here at the Sensible City Lab, just showing where we are, because during this pandemic, we said, okay, but does this MIT exist? Yes, it does exist. This is our main building, although depending when you are here, it's basically covered by snow. I remember when I started here, I had this image in mind. Then it was completely blanketed with snow, but it's a very vibrant environment. And not only the institute is vibrant, but I think what is important also is what we have inside Sensible City Lab, and it's a very particular place within MIT. And also, I believe it's a very particular place within several schools of architecture and planning in the world. And why is that? Because actually, for two reasons. The first one is that although we are part of the School of Architecture and Planning, we have several researchers with very different background. So I work side by side with mathematicians and physicists and designers and sometimes economists and political scientists. And this mix brings new ways of seeing the same urban phenomenon. And I think this is quite important, not only because I know that somebody just in the desk in front of me is working in the same problem with an economics perspective, but actually, as you can see here in this graph, several projects, we have different people working in the same project, but these people, they're also working in multiple projects. What it means is that we have this multiple perspective contributing to bring new ways of looking at urban phenomena. And the lab has been doing work in different countries, and this is not the countries where, or the cities where we are doing projects. So for instance, here, what we don't have, as you can see, oh, but where is Stockholm here? So these are only the cities with which we signed a special arrangement to do what we call the Sensible Guide 2. So we put students together, students from the School of Architecture, Urban Studies, Computer Science here at MIT, for a semester-long course focused on one city in particular. And we work with city officials for one semester to propose some new ways of thinking how technology might change the way the city is dealing with a specific problem. And this is quite interesting. It's not because, oh, so why these students are coming here and trying to solve our problems. It's not the point. Our point is that perhaps we can bring some fresh eyes to cities that are struggling in finding solutions to one or two specific components. For instance, this year we have been working with one city in Canada called Laval and another one in Brazil called Curitiba. And in one case, they are building a new park in an old quarry in a pretty central area of Laval. And in the other case, in Curitiba, they are trying to see how they can use digital technologies to transform public transportation, which is a key component of the city. So I think this is what we've been doing all over the world. And why we think this is important. This picture is pretty famous, but sometimes we don't realize that cities occupy only 2% of the Earth crust, even though we have more than 50% of the population living in cities, and we're responsible for 75% of energy consumption and 80% of CO2 related emissions. So the impact that our way of life, our urban way of life have in the world is pretty big. And more importantly, we also have this gap that we're trying to bridge between the physical and social layer of cities with this digital but also social layer that we have with digital technologies. So the Sensible City Lab tries to find these gaps and then bridge these gaps and try to create new ways of understanding cities and sometimes new ways of designing the cities in this area between these two layers. What I'm planning to show to you today will not involve design. So, and we do have some projects that we actually not only do the analysis of urban phenomena, but also propose some projects to either provide some solutions or at least new ways of navigating, literally sometimes, these new phenomena. But what I'm going to show today is more on the research side. So how we can use data to understand cities in novel ways. And when I mention about data, oh, but we've been using data for a long time. That's true. But the lab has also, I would say, a dual personality. On the one hand, and this will mark the three projects that I will show you today. On the one hand, we simply get all the data that we are producing daily. So as we all know, every time that you use your cell phone, you are pinging a data to an antenna and it's collected and I can track you. So all this data that we generated endlessly in our daily lives, we are trying to collect part of this data and to see whether they are showing us different aspects of the city, or at least ways of looking at the city that we're not able to do a few years ago. However, sometimes we need to collect data firsthand. So here, what we can see, I just give two examples of this image, but sometimes we go to the sewage system to collect sewage samples and bring to the lab to see what we can find there. And then eventually this project called Underworlds, we build some small robots that can collect and do preliminary analysis automatically of the samples in the city. And now it became a startup doing COVID tracing in more than 200 cities in the United States. And also sometimes we go on trash trucks to deploy sensors to collect air quality data. So the lab has these two aspects. On the one hand, we scrap data from the internet, or we receive data from sponsors, and then we try to find new ways of seeing urban phenomena through this data. But also sometimes we go to the cities to collect this data firsthand, and both aspects are pretty important for us. But also we believe that besides doing academic analysis and publishing scientific papers, we need to communicate these findings to the general public. Otherwise, it would be almost talking into a echo chamber that everybody knows already what we'll be talking about, etc. So what we want to do is to engage the non-scientific community into the conversation. So when we bring this data visualization to a museum or through a beautiful website that captures the attention of media outlets, it's a way of bringing the general public into science. They see the visualization and they say, oh, the visualization is beautiful, it's telling a appealing story. Let me find out more about the science behind it. And we're doing this pretty successfully for a few years. And we think this is also a core aspect of the Sensible City Lab. And the three projects that I will show you today, it starts with desirable streets. And this project, Desirable Streets, we had some questions in mind. The first one was that first, the data. Where does data come from? So a few years ago, 3 years ago, we partnered with an app called Breeze. And basically what it intends to do is to track how many steps you take in one day, where we go, as many other apps do, right? And then in a previous project, we were able to see areas in the city where women used to use more than men in different times of the day, in different days of the week. We also compare San Francisco and Boston to see whether socioeconomics or weather influence how people walk in cities. And this is quite interesting because it's not a survey. We simply collect this data that people were using this app for their own purpose. We did not interfere at all in collecting this data. Simply, look, people were using this app, and then eventually we collect hundreds of thousands of traces of pedestrians inside the city, and then we could start monitoring their natural traces in urban environments. This was a first take. But then here we said, okay, but we found something quite interesting. And the interesting point was that we start to compare, let's take any trip of these hundreds of thousands from point A to point B, and let's see which would be the shortest path from going from A to B. And let's see whether people actually take the shortest path or not. And we found that more than 20% of each journey were not taking the shortest path. Then first we said, okay, well, if people are not taking the shortest path, what are making them take the longest path? And our question again, if they're not taking the shortest path, do the longest path have some commonalities? And we found that they do. Actually, we found that when people decide to deviate from their shortest path, they tend to prefer some streets over others. And then our question, okay, why people prefer to deviate from the shortest path? And when they do deviate, they take specific street segments in Boston. And so here you see Boston with all the path, and the highlights are the path that were taking more for people deviating from their path. And what we found, let me play the short video here, and then we start to compare different paths. So you see here two paths, and one of them, obviously you see on the left, you see the path actually taken, and on the right, you see the shortest path. And then we start saying, okay, look, there are some commonalities. We could see that there are some commonalities why people were deviating from the shortest path and taking longest path. And these street segments, they had some features that perhaps could explain why people were doing that. But these are kind of three examples that I can show you, okay, look, there is more greenery, there are more sidewalks, they have more furniture, they have more business. On the other hand, on the right-hand side, it's a kind of a more dry urban feature. But we could not only stay with this visual aspect. So what we did as a way of explaining this, then we collect all Google Street View images from the city, and we have these thousands of images labeled with, okay, this is greenery, this is business, this is furniture, etc. And then we labeled all the images of Cambridge, and we start to see first whether in the desirable streets we had certain elements that were not in the shortest path. On top of that, we also include some amenities such as shops or major roads and quieter roads, also access to green spaces. And then we have all this data in a same data set to try to explain, okay, people take shortest path when they have some things that are quite intuitive, but when they walk closer to parks, when they have more street furniture and wider, or at least some sidewalk, or they have business access. Not only the amount of restaurants, for instance, but diversity. So one thing that we could prove is that desirable streets, at least in the case of Boston, business make a street more desirable than others. However, not only the number of businesses, but also the diversity, and more importantly, the diversity of business. So let's say if we have 5 restaurants, you attract more people than if you have only 1. But if you have 5 restaurants or 10 restaurants, it doesn't matter anymore, unless you start to diversify the type of restaurant. So this type of information for us was, some of the results were pretty intuitive and others were quite new. But the important thing about the intuitive side is when you can prove with data and you can find a solid and scientific explanation how this intuitive knowledge of city actually happened. And so now we are doing the same study comparing San Francisco and Boston. Another project that we did recently, also to understand the urban landscape, and this was what Andrew mentioned, the third project that I'd like to bring to this talk today, is called Sonic Cities. And again, it was a way of trying to understand what we knew, or at least we had heard, that was happening in cities in a more subjective or intuitive way. So when the pandemic started, we started reading some news in different media outlets saying, oh, now that we don't have as much traffic, I can hear birds, I can hear people talking on the streets. There are some sounds that we simply had forgotten that exist in cities. And our question is like, yeah, I agree. Intuitively, I agree. I can hear birds that I was not hearing before. But is this true or not? So what we did to prove that? First, it was almost kind of an impossible question because, okay, now we are in the middle of the pandemic. So I can even go there and record the sounds of the city. But what about the sounds of the city prior to the pandemic? That was the first challenge. The second challenge was that, okay, but where should we collect this data? And we also have some anecdotal stories that parks kept being used more than any other open areas during the pandemic. And this is also true for Stockholm. Just to very soon, with some colleagues from Stockholm, we'll be publishing a paper to see which spaces in the city of Stockholm have been more and less used during the pandemics in different parts of the city for different types of population. And we found actually that parks were one of the main features that kept its livability more than other open areas in the city. But going back to here, so what we did, how we did this to collect this information prior to the pandemic, because remember, we're not concerned with noise. It's not that cities before the pandemic was much noisier than during the pandemic. The point was that, okay, could we hear different things before and during the pandemic? Then we found that people upload almost everything on YouTube, including when they were walking through parks with their cell phones, and they were kind of filming their walk, sometimes narrating, oh, this is what I'm seeing, etc. But we found some footage of people simply walking through Central Park in New York. It was the first one that we did. Simply walking through the park with a cell phone. And then with sound. And then we said, oh, if they have done this in Central Park, we can do the same in different cities. So basically, we start collecting YouTube videos before the pandemic with sound. And then we contact some colleagues. So we simply select cities where we had some colleagues available to take the same path twice in the first month of the pandemic. So in March and May. And then because we had the actual path of people walking through Central Park, through one park in Milan, another one in Singapore, we call some friends, okay, look, could you go there and also take a video of this journey? And they went there. And then what's interesting, oops, why not moving? And so what is interesting is that first, we could see that park activity was actually more intense during the pandemic than any other public or collective used space in cities. So workplace, transit, parks, you can see that the drop is not as accentuated as transit or workplace, and then it come back pretty soon during the pandemic. And what we found is that not what we found, before what we found, and how we did that. So then we also found that there are many libraries, sound libraries on the internet. So you can see children crying, ambulance, garbage trucks, all these sound libraries in the internet. So then we trained a model saying, look, this is what children crying sound like. So we have dozens of them. This is how a trash truck sound like. We have dozens of them. And then we uploaded our soundscape, our journey through these parks. And then the algorithm started to classify what it was sounding. So if you hear this, let me see if it's too loud, I can put it down. So if you go on the website now, you can try to track. So basically, this is what you are hearing is the soundscape of Manhattan before COVID-19. And then if you can go there and you see the soundscape of Central Park during COVID-19. And also you can isolate each sound type, birds or sirens or human activity, etc. So this was a way not only for us in our goal, it was not only to prove or to test whether the soundscape of the cities had actually changed before and during the COVID, but also to describe what had actually changed and how much they have actually changed. So this for us is quite, as scientists, is quite important because for a few reasons. First of all, it's important to prove, to show with data and with empirical data, something that we can understand subjectively or intuitively. So now we have data to prove. And secondly, I think is this imagination of finding data that exists already, and it's only a way of bringing the good questions and this perception that, okay, probably this data is available. How can I grab this data and put this different data together to answer a nice question and respond this question? And finally, so this is a comparison between the cities. You can see online all the results. And also I would like to finish with a final project that we launched last month called Favela 4D. And Favelas 4D, Favelas is an informal settlement, is a slum that we have in many developing countries. This is in Brazil, I'm from Brazil. And what we have here is that these informal settlements, they are very complex urban settlements. First, they are unplanned and they grow spontaneously. And obviously, as they are informal, the city itself has a pretty challenge in their hands, is that they know that they have sometimes thousands of families living there. On the one hand, they need to provide services, at least some security. On the other hand, most of the times they do not legalize the area, because by legalizing the area, they might be giving away private or public land to this population. So the problem is pretty complex from the legal perspective, from a political perspective, but also from a spatial perspective. And often these environments, they remain unmapped. And when they are not mapped, it's difficult to provide service to them. And services going from sewage to simply a postal code. So there is an article, a short article in the last MIT Technology Review about India, in a case that a girl opens the article, say, okay, oh, for the first time in my life, I could order a pizza that all my friends were doing and I couldn't do because I did not have an address. And it's a very anecdotal case, but what happens is that once you are there in an environment with thousands of houses, and even though you have thousands of houses, you cannot say where you live because you don't have an address. It's a pretty difficult situation for many aspects. And what we did, so we decided we partnered with some colleagues in Rio, and we said, okay, let's try to see if we can use LiDAR. LiDAR is a laser scanning. So basically, you can imagine it's a kind of a device the size of a small notebook, that it has some laser beams. And every time that the laser beams being hit some object, and it bounces, you measure the distance between the source and the object that the laser beam bounced. And then they were already, there was a team from the city going there to provide new service to this favela in Rio called Rocinha, where we have 100,000 inhabitants, more or less. And it's a very well-established and well-mapped favela in Rio. Therefore, we could have a ground truth. So let's see whether we can have the same information as the official maps already have, and let's see that we can add some information. And for us, the main information is to measure the vertical complexity of this environment. And why? Because obviously, we have companies doing an amazing job in mapping these informal settlements using satellite imagery. However, they have two challenges. One of them is obstruction. If we have, let's say, trees, or if we have these urban environments, they grow in very complex 3D, in a very complex 3D manner. So one house might be blocking the other house. The streets are, some of them, they're actually alleys 1.5 meters. So we have too much occlusion. So it's not difficult to lose information when we have only satellite imagery of these environments. And also, they have a very precise measurement of how these settlements grow horizontally, but not that much as they grow vertically. So this is what we did for Rocinha in Rio. So this is a pretty consolidated informal settlement.